days of driving, yeah. Yeah, it's a fun drive.
All right, we're gonna, I guess it's up to us to get things going. Are the microphones on and working? Yes? Okay, great. Thank you very much for everyone for being here. I am Allison Sekuler. I am the President and Chief Scientist at the Center for Aging and Brain Health Innovation, as well as the Baycrest Academy for Research and Education. And it is a pleasure to have this amazing panel with us today to be talking about Toward Dementia Zero. We'll explain what that means. The collision of technologies, precision aging, and predictive neuroscience. It will all become clear what we're talking about as we start to talk. I will, in turn, be having each of our panelists introduce themselves, but just briefly, I will say we've got Jay Ingram and Angela Tom and Jehangir Appoo, and they will introduce themselves and give a little bit of their background in a moment. But I'll just first start by saying, when we're talking about Dementia Zero, what is Dementia Zero? We're talking about, we were thinking about net zero and how we want to get by the year 2050 to, reduce the net emissions and so on. We're thinking, well, for dementia, why don't we try to get to net zero for dementia? That's what Dementia Zero is really about. By the year 2050, can we end up in a place where no more people are being diagnosed with dementia, where no one is moving into a long-term care home because they have dementia, and where no one is dying from dementia? And at CABI, the way that we think about how we might be able to get there, and this is true for Baycrest as well, is by thinking, well, how can technology help us to move in that direction? And it's not like a technology is going to do that, but we think that there are lots and lots of different technologies, and how can we put all of the different technologies together? How can they collide in different ways to help us move toward that moonshot goal of Dementia Zero? That's really what we're aiming to do. And that's in the Baycrest Academy, the kind of research that we work on. In CABI, it's the kind of work that we do. And just for people who don't know CABI, the Center for Aging, Brain Health Innovation, I know some of our staff are here. If you want to raise your hands, I saw some of the staff here before, or did they escape? There they are back there. We have a booth downstairs, so come on by and check out the booth. There's actually a draw for is it a Muse S or a Muse 2? An S. Okay, so actually I have one here because I always have one with me. Everyone should. This is Interaxon's a company that has this wonderful device. You might have seen it. It's a headband, also an EEG system, and we're giving one of these away. If you come to the booth, you can win one of these. And it's to help with mindfulness, meditation, and so on and so forth, which is one of the kind of technologies we can be talking about. But what we try to do at CABI is to work across the entire ecosystem of aging and brain health for innovation. And that's all the way from people who don't even know that they're entrepreneurs, so people, frontline care workers who work day in and day out with people living with dementia, with older people, with other kinds of neurocognitive impairment. They've got great ideas. They know what works for the people with whom they work, and we want to help them spread and scale that. So we help them develop themselves as entrepreneurs. We also work in the intermediate stages, people who have an idea and they want to figure out, how can I test this in real world settings? Or how can I revise it and refine it in different ways to make it work better? All the way through spreading and scaling and adoption. And we even have an investment arm. We're doing equity investments in some companies, including Perceiv AI, which we'll be talking about in a little bit. Although we're doing it currently in the context of a nonprofit, there's hope that we may be able to start a venture fund down the road to be able to have an even bigger impact there. So we can talk about more of that later. The areas in which we are funding all of these different kinds of projects include cognitive and mental health, caregiver support, care coordination, aging in your place of your choice, usually at home, as well as our newest area of focus, which is financial health and wellness. And you might say, well, what's financial health and wellness got to do with the brain? Well, if you aren't able to take care of your own finances, you're going to end up in more stress and more distress and end up potentially having to move into long-term care sooner. So we see all of these as connected, and we have grounding themes that sort of cut across all of these for supporting diversity, inclusion, equity, working with diverse groups, as well as for reducing stigma and for promoting social inclusion. And on that note, the last thing that I'll say before I turn it over to Jay for his introductory comments is that Jay and I actually are going to be starting a new podcast. And the title is TBD, which might stand for TB Dementia, we just decided, we don't really know. And it's going to be focusing on what you can do to prevent dementia and to reduce the stigma associated with aging and dementia. So look for that. Do you know when is it supposed to be coming out?
Sometime
soon. Anyway, it's going to be awesome, as you can tell. And so...
TBD.
TBD.
It has all the earmarks of being awesome, doesn't it? Yeah.
So it'll be terrific. And if people have suggestions for what you'd like to hear in it or what you'd like to learn about in it, please come to us afterward and share your perspectives, because we really want to co-develop it with the community. So with that, I want to turn it over to Jay for your introductory comments.
Hi, everybody. I'm Jay Ingram. I don't have a booth, and I have no giveaways. So that contrasts me with Allison. But I've been in the business of communicating science to the general public for longer than I actually want to admit. So my job here in the next 5 minutes or so is to just outline where we stand with dementia. Usually I'm talking about Alzheimer's. There are, of course, several dementias. Some of them overlap. Just so that it kind of opens the door to what the possibilities might be for technological assistance in this issue. By 2050, that's a handy date, it's estimated there'll be 150 million Alzheimer's patients in the world. So that is a dramatic number. The numbers are rising pretty much consistently around the world as the post-World War II boom of population moves into the susceptible ages. There is a tiny encouraging note that in many of the developed countries, the rate of increase is slowing. It's not actually clear why that is, but in many other parts of the world, the rates are consistent or even rising in some cases. In Canada, it's anticipated that by 2030, not that many years from now, we'll have 1 million cases. So treatments, where do we stand with treatments? This is going to be a very brief discussion. There are none. I will have to caveat that by saying there have been 2 drug treatments approved by the FDA in the United States. The approval is extremely controversial among Alzheimer's clinicians and researchers because the effects, the slowing of cognitive loss, not an increase in cognition, the slowing of loss is barely significant. The cost is enormous, estimated lecanemab, the latest, maybe $25,000 a year US. A handful of people have died of brain bleeds, which haven't definitively been linked to the drug, but probably are. So there really are no effective treatments. And so lecanemab has been approved, but I'll just read you what the British Medical Journal had to say about it. Lecanemab is not the hoped-for game changer. Rather, it's further evidence that anti-amyloid therapies, of which it is one of the group, do not produce clinically meaningful benefits for people with Alzheimer's disease. That's treatments. Cause. That's partly related to the lack of success in treatments, because while there are people who are convinced that the amyloid buildup in the brain is the cause, there are reasons to think that it isn't the entire cause or may not even be the cause. So clearly, there's a huge opportunity here in the next couple of decades for genomics, proteomics, metabolomics, everything, to really try and nail down the cause. Because once you have the cause, then surely a treatment is easier to look for. Diagnosis. So this is a tricky question at the moment. There are techniques for detecting amyloid and tau, another protein that accumulates in the brain. There are techniques coming online. Carleton University just announced today that they have a saliva test, although if you read the article in the Toronto Star, it becomes clear that they've never actually tested it with real patients. They've tested it with people like you and me, they take saliva and then they add Alzheimer's proteins to it and then test it. But it might be the real deal. So diagnosis right now, why would you have it if there's no treatment? So some people want to plan their future, their family, and everything else. I applaud that. There's nothing wrong with that. But just so you know, when a diagnostic comes, unless it's coupled with a real solid treatment, it kind of leaves a gap. Genetics, Allison and I like to say that, in fact, everybody thinks they're going to get it because Aunt Mabel went dotty when she was 80. And she was my aunt, so I'm going to get it. That can't be further from the truth. If your parents both got early onset Alzheimer's, like when they were in their 50s, then it's probable that you've inherited a gene that will determine you get it. But all, aside from early onset, all late onset Alzheimer's from like 75 on, may have a genetic component that may raise your risk, but you may have that gene and your risk somehow doesn't give you Alzheimer's. I've seen stats where 50% of those who have the two worst genes that are well known still don't get dementia. So we need to know a lot about the genetics. That's another research opportunity. I almost called you Alzheimer. Allison. Jeez, talk about a one-track mind. So Allison and I and our About to Happen podcast are really concerned about informing the general public that there are risks that you can do something about to lower your risk for dementia. Across the population, about 40% of dementias are due to these malleable risks. And it's appalling, I think, that people aren't aware of these because, you know, it's up to you to choose whether you stay more physically fit, stay more socially interactive, regulate your blood pressure, deal with your diabetes, don't drink so much, don't smoke. That's up to you. But to know about it is the critical first test. I didn't keep time, so I'm going to talk for one more minute about care. It's estimated that millions more caregivers, if you pair this with the accelerating or at least the rising numbers that I mentioned, millions more caregivers worldwide will be needed. If any of you have been either an informal or a family caregiver or even a caregiver in an institution, you know how incredibly draining and stressful that is. The more draining and stressful it is for the caregiver, the less well they can give care. This is a huge issue, and if we're talking about technology and AI, the inevitable question becomes, what about robots? Allison knows a lot more about robots than I, but I'll just sort of sketch this out for you very quickly. What about humanoid robots? Well, let's start with pets. Okay, there are many experiments have been done giving residents in long-term care homes artificial pets, little cats, dogs. There's a famous seal called Paro. I'll talk about Paro. It's aware of the surroundings, it can hear, it can make noises, it can respond to your touch. And in many cases, people really take to these. That's step one. I should also say that scientific papers have been published arguing that quality studies of these don't exist. So to be able to say, yes, they're going to be a magnificent help to care, you really can't say that with 100% confidence at this point. So maybe not pets. What about humanoid robots? Humanoid robots that are a lot more skillful than what even Boston Dynamics can do right now. But, you know, an acceptably human form that moves around the room and talks to you and turns on the TV for you, maybe even helps, it reminds you what to eat, maybe helps you eat. Is there anything wrong with that? The argument that's commonly heard against humanoid robot caregivers is they're robots. They can't feel empathy. They're not human. It's not appropriate for that reason. I'm not convinced by that reason because a year ago you would never have thought a chatbot could convince you that it was a human being. And there's going to be a huge acceleration in the humanoidness of robots. But there's an ethical argument attached to this too, which is do we want to participate in deluding the person for whom the robot is caring into thinking that they're a human when they aren't really? And attached to that is another ethical argument which says, okay, robots start to come on stream. They're going to be cheaper because by that point they won't be super expensive as they are now. Okay, so it's going to be more expensive to have a human caregiver than a robot caregiver. And does that mean we're automatically separating that cohort of people who need care into the privileged and the not privileged? So I'll stop there and hope that I've at least opened a couple of doors for the two that are to come, and that's it. Thank you.
Yeah, and just before Angela starts, I mean, so one of the issues that's been raised there, and hopefully y'all can be following up on this, is you know, yes, there's robots, but there's also large language models, and there's AI, and you know, devices like this that can basically read your mind, eventually telling you what emotion someone is feeling. So, you know, putting all of these together, that's when you're talking about where the power is coming from. And Angela, the work that y'all are already doing is already starting to combine some of these elements. And I wonder if you can share what it is that you do and how it fits in our theme today.
Yeah, so hi everyone, my name's Angela Tam. I'm a senior scientist at Perceiv AI. I have a PhD in neuroscience from McGill University, and I have over 10 years of experience developing multimodal predictive tools, and more specifically, my expertise lies in combining brain imaging and machine learning to predict clinical outcomes. So Perceiv AI is a precision medicine company. We are based out of Montreal, and we are focused on forecasting disease progression. So one of the biggest challenges to tackling a complex disease such as Alzheimer's disease is that there is high variability in patient progression. So we really need to ask ourselves, how can we make good decisions for patients when we don't really know what is going to come next for them? So in Alzheimer's disease, we see that a lack of good prognostic tools has led to high clinical trial failure rates, more expensive clinical trials, and ultimately delayed diagnosis and delayed treatment options for patients. So our flagship prognostic product is in Alzheimer's disease, and what it does is it predicts your risk of cognitive decline across the disease spectrum. So ranging from very early pre-symptomatic phases to mild cognitive impairment, all the way to the dementia stage. We use this tool to de-risk clinical trials. By selecting a higher quality population, we can reduce sample sizes and increase a trial's likelihood of meeting its endpoints and therefore having a successful trial. This has multiple benefits ranging from reductions in costs of running a clinical trial, shorter trial durations, and most importantly, testing the right patients. We also use this tool to support clinicians to arrive at a more timelier diagnosis, and this can reduce the period that is spent watchful waiting for the patient. How we do this is we've built a prognostic platform that leverages an extensive longitudinal and multimodal database. So we support imaging, clinical assessments, cognitive tests, genetics, and different biomarkers for Alzheimer's disease stemming from blood and cerebrospinal fluid, for example. So by aggregating all of these modalities that are typically acquired by clinical trials and clinical settings, we can train machine learning models on all of this data to predict individual patients' futures. What we really want to do is bring better prognostic tools to patients, especially because, like Jay mentioned, I mean, I have a different professional opinion about this, but with the advent of disease-modifying drugs, it's really going to be a game changer. I really feel like we've reached a stage where we can actually realize the potential to delay or perhaps even prevent altogether the onset of dementia symptoms in patients who are at high risk of cognitive decline and at high risk of getting Alzheimer's disease. And the successes of clinical trials done by Biogen, SI, and Eli Lilly, they're all anti-amyloid therapies, and I wouldn't say that amyloid is the only answer, but it is definitely a big part of the answer to bringing good treatment options for patients living with this disease. And how I feel that AI can play an important role in this is because Alzheimer's disease is a multifaceted, complex disorder, and there are so many different risk factors that can account for why a patient will or won't progress as fast as a different patient, even though they have essentially the same disease. And a single biomarker can't tell you, a single biomarker can have a lot of value, but it can only tell you so much. It can only show you one part of a patient's story. And with artificial intelligence, it can leverage data coming from multiple modalities in order to bring you a more holistic view of a patient's future trajectory. And so with artificial intelligence, I think we can build really good tools for prognosis and earlier detection so that we can bring good insights into how a patient is going to evolve over time that is really tailored and personalized to them. And so we can actually deliver the level of care that patients truly deserve. So what we hope to achieve with Perceiv AI in the near term is to continue to solve bottlenecks in clinical trials in Alzheimer's disease by offering them enhanced patient selection. We want to bring clinical decision support tools to clinicians to arrive at a timelier diagnosis in Alzheimer's disease. And we want to eventually expand to other age-related neurodegenerative disorders such as Parkinson's disease and multiple sclerosis, because they're also complex diseases like Alzheimer's disease where there's a lot of heterogeneity and variability in how patients progress over time. And so these diseases would really benefit from a more precision medicine approach that is supported by prognostic tools built with artificial intelligence. So I think I'm going to stop there. If any of this interests you, please reach out to me. I'm always very happy to have a conversation, and I look forward to speaking with you.
Yeah, and you've got some materials at the Cabby booth as well.
Yes, that's right.
So
There's
people can come by the Cabby booth
yeah.
and check that out as well. And in terms of the AI's ability to combine information, I mean, one of the things, we'll come back to this in a bit, is you've got a set of data that you're integrating right now, but like who's got an Apple Watch on or a Fitbit or whatever, raise your hand. I mean, you're all being sensed right now, right? And so there's all kinds of, biomarkers, digital biomarkers that we're all increasingly using. So the more those are just part of our everyday life, the more all of this can kind of get integrated into these models to make them even more specific and predictive. So Jehangir, I wonder what your thoughts are on the discussion so far, and you're speaking from the investor perspective, also as an MD, who's seen kind of both sides of the coin, if you will. And what are your thoughts on the topic?
Yeah, so is this working? Yeah. So thanks for having me, Allison. Thanks for everyone for being here. And yeah, like Allison had provided a few questions, and I was going to sort of frame these around, like from the investment point of view and entrepreneurship, in case there's entrepreneurs in the room who are building these technologies. My background is in a combination of venture capital, academic medicine, and clinical surgery. I started a venture capital fund about 3.5 years ago, focusing on a lot of the things that Angela mentioned, investing in the use of AI to deliver personalized medicine in healthcare. I also, as of this year, lead a venture philanthropy fund, which is a little bit different, at USEED, which is part of the University of Calgary system. And on the academic side, I run multi-center trials in cardiac sciences internationally. And previously, I was a heart surgeon for a couple of decades where I built new programs and scaled them. So in terms of Dementia Zero and what's exciting from an investing point of view, Angela was asking me what does a venture capital fund look for in an investment? My first thought is that there's so many different types of venture capital funds, and everyone's got a different thesis, and you can't always have a thesis fit. So you need to find, that match. But then even before that, not every company needs to be venture backable. There's this concept from Sequoia that the product that venture capital sells is actually, is the cash, right? But it's actually jet fuel. And not everybody's looking to build a rocket ship. You might be building this totally amazing motorcycle or scooter. You don't need jet fuel for that. So you have to match your source of capital with what you're trying to do. So there are multiple sources of funding a very good business, from bootstrapping from debt to venture debt to foundations, to venture philanthropy, to venture capital. So that would be the first thing is like, it's not always venture capital is the right fit. And so venture capital is really about scaling. So I could talk a little bit about, from my fund at AioT Health, so Artificial Intelligence of Things Healthcare, we're like, what are we looking for? So like in our screening paradigm, we have like 3 things that we look for. So for us, it's around impact. So can we see line of sight to this technology potentially affecting greater than 10% of humanity, right? If it's going to be something big like rocket ship, Allison earlier referred to moonshot, right? So can we see this technology, not initially in its beachhead market, but eventually, can we see how 10% of humanity may be using this technology? And then secondly, for us on the venture capital side, is it 10x different than the current standard of care? The output that comes out, does it actually make a humongous difference versus incremental difference? And I think this is kind of important because there's a lot of incremental changes that are really, really beneficial. And if we add up all these incremental changes that people do, it makes a huge impact on humanity. So it's really important to support and for it to occur and people to work on those things. However, sometimes incremental changes aren't always venture backable, getting to the finance side. So, that's the second thing for us. Is it 10x different? And thirdly, from a venture capital side, we're looking for founders who are thinking differently. We're not doing the same thing that everybody else is doing, so we call that like an untapped market, right, where there isn't a lot of competition. So, and that, I would say, is generalizable across all different disease processes, organ systems, not necessarily for aging, but that's kind of like a framework how we, as a VC, would look at investing. And then, Allison asked about like what kind of things are exciting to us right now, like what types of technologies would we be interested in? So I thought about like 3 things. So one thing that I think is really interesting in 2023 in today's world, as opposed to sort of previously, is we have these medical devices that are hardware, but they can actually. Oh, is that 15 minutes left? Is that what you're saying? Okay, sorry. Yeah. I wasn't sure. Okay.
Is that a protest? It's okay.
So yeah, okay. So one cool area that we kind of look for is people talk about software today, and there's a podcast out there like Software Eats the World. Bio Eats the World. There's a podcast on that. And then there's hardware, medical devices. What's really interesting to us is where you have hardware that improves with software updates. Right? So it used to be a medical device was like a new hip, and you implant it, and it was fixed forever. But when you can use like this kind of, almost like what I consider the Tesla model, people buy the Tesla because they enjoy driving it. It takes them from place A to B, but the product continuously improves through software. So like I'm wearing an Oura ring right now, right? So I'm getting some benefit from this in terms of sleep and sleep health and monitoring my activity, but the device is continuously improving because over 1 million people are providing data second by second. Yeah. So I think from an entrepreneur point of view, or at least from an investment point of view, it's super interesting where you can have hardware that improves because of software updates and it's not static. So I find that to be an interesting investment area today. At our fund, another thing that we're interested in is this idea of like nocturnal health. Like as humans, we spend 20 to 30% of our life sleeping, but what's really going on when we sleep? So there's circadian rhythms. Our enzymes aren't the same, day and night. There's do we know what's happening with our blood pressure at night? And if our blood pressure is high at night, does the kidney say, oh, it doesn't count because it's nighttime and you're dreaming, so it's not affecting my organ system, right? So those are sort of like some areas that are fun that we're interested in. And then finally, like Allison asked about where this field is moving and some of the challenges from an entrepreneur point of view. So in my sort of I've spent 25 years in clinical medicine, and when young students ask me, what are interesting areas to go into medicine, there's a bunch of different things. They'll all be interesting, but 3 of the most exciting areas to me, one of the 3 is neurosciences. And the reason for that is, until recently, the brain has been a black box. We had very, very rudimentary tools to assess what's going on in the brain. But with the advent of so much technology, and specifically imaging technology and PET scanning and MRI and functional MRI and cerebral oximetry, this has opened up the brain for examination, and this whole idea of brain-computer interface is a super interesting area, I think, going forward. And what should entrepreneurs look for? Like, again, these, what VCs look for are big challenges. Like, again, Allison referred to moonshots, Dementia Zero, 2050. That's super exciting when you take on big problems. And then also we talked earlier about what Jay brought up is like, there's so much out there in the diagnostic space, but if it's not actionable, it may not be really a sustainable business, right? So you want to match diagnosis with something you can do about it, and I think that's kind of a key thing. And then, of course, we're really interested in this robotics and AI combination, and I think we could have probably a whole panel on humanoid robots and the pros and cons of that in terms of aging, and there's various different lenses to look at that.
Yeah, especially when you link it with brain-computer interfaces and all of that kind of thing.
Yeah.
I want to come back to something that you and Jay said, and Angela put her hand up and said, no, you're wrong, which is this idea that even if you do find out about it, there's nothing you can do about it. I think that you would disagree with that, correct?
Well, actually, there was a study commissioned by the Alzheimer's Association in the United States in 2018 that found that for all individuals who are alive at that time and who would eventually develop Alzheimer's disease dementia during the course of their lifetimes, if these patients would have had access to earlier diagnosis, $7 trillion would be $7 trillion associated with their medical care costs and long-term care costs could be saved. And this was even before accounting for a potential disease-modifying drug. And now that there are going to soon be like 2 or 3 in the market really soon, at least in the U.S.
Yeah,
and I could put a different lens on that, right? Like, so that's totally true. The other lens is like if one is building a business, right? Like the business is not going to save $7 trillion, for a particular customer or something like that. So for the business to be sustainable and to be able to do that diagnosis, it needs to have something easy that is actionable for whoever is purchasing their technology, right? So the end effect might be $7 trillion saved, but right. Trying to build a business to do that is probably not sustainable over time, and you can't get your first customers and second and move on. So totally agree with what Angela says, but if one's building a business to do something in the diagnostic space, ensure that there's 1 or 2 easy things that somebody can do with your diagnosis that is immediately actionable. Yeah. Right?
Yeah. Well, it's some of the things, Jay, that you were talking about that are preventative kinds of things. We actually think it's at least probably 50% now of the risk factor can be modified by lifestyle changes. And it's likely to be bigger. Like just today, we were just talking about another X% was just found to be potentially risk reduction if you get your shingles vaccine, right? So there's new ideas about how to reduce the risk coming every single day. So if some of these things, maybe like education. Childhood education, yes, when you are 60 or 70, it's too late to go back in time and change your childhood education. But there are other things like detecting hearing loss, changing your sleep patterns, watching your diet, and you're doing things that help your heart are also going to help your brain. And so there are some things that you can do to, if not to prevent dementia, aren't there things that you can be doing to delay the progression and increase the quality of life? Would you agree with that? Or?
Yeah, I think it would depend on how early or how old you were when the diagnosis came.
And how far along maybe the disease
is. Yeah, because these risks that we're talking about have been identified as being significant at different phases in life. So if it's hypertension, you want to be dealing with that when you're 40 to 50 years old, not when you're 75 or 80. Same with obesity, same with diabetes. Some of the others like maintaining social contacts and walking, being fit, those appear to have more significant effect later in life. So this whole business about diagnosis without a treatment is somewhat time sensitive as well. If you're going to change your behavior, and I mean, changing behavior, maybe the threat of dementia is a powerful trigger for that, but there's usually a big gap between telling people what they should do and having them do it.
Yeah, and we also think that there might be other cures or treatments, I should say, on the horizon related to brain stimulation, the glymphatic system. We've been doing lots of work related to those sorts of things. There's other areas that could be emerging, right?
And I should say I don't disagree with Angela in thinking about these drugs that I kind of said are not ready for prime time, because I don't think they're ready for prime time right now. But they do suggest that these targets of the drugs actually do play a role, because the drugs wouldn't work even to the level they do if they weren't the right target. And that should have an impact on the controversy that's existed within the Alzheimer's community about whether amyloid and tau, those deposits, are actually really the cause at all. So, like, my personal view is, and what do I know? I don't have an exhibit and I don't have a giveaway today. But
But you will have a podcast.
I think in 10 years, it wouldn't be surprising that drugs like this are playing a much more significant role.
Can I say something?
Yeah, please.
So, like, I'll just pick up on your theme of personal, and that may be one of the ways forward is like around personalized medicine, and that also tying in like what Angela is doing, right? It could be that these drugs that you referenced, Jay, that the results were sort of ambiguous, maybe at best, is because they may have helped some patients, but we
Not
didn't
the
know
right
which
patients.
patients are going to
Yeah.
help. So if we try it on 10,000 patients and it helps 1,000 and we measure the effect on all 10,000, maybe it's not that useful. But using technology, like maybe Perceiv AI, we can predict which patients are going to deteriorate faster with Alzheimer's. And if you could detect that and try these drugs out in that subgroup.
Or deteriorating in a certain way.
Right,
Yeah.
exactly. So then you get into this personalized treatment. So until now, the history of medicine has been around the major advances like this randomized controlled trial. Take 10,000 patients with therapy A, 10,000 patients with therapy B, and 75% of patients with therapy A do better, and only 52% of therapy B do well. So then we give everybody therapy A. That's kind of like how we've done medicine today, and it's worked really well. Like tremendous advances in 120 years. The next layer, I think, is around that personalized medicine.
Yeah, for sure.
So just to expand on what Jehangir just said, a lot of the failures in Alzheimer's disease clinical trials is because, so basically they haven't detected any significant effects between placebo and treatment arms. And a lot of the times it's because the placebo arms do not decline over time. So at baseline versus their endpoint, there's not much change. And a big reason for that is because like a significant minority of people stay very stable within the typical duration of a clinical trial of like 2 or 3 years. And so what we propose at Perceiv is that you don't want to select these people for your trial. They're not going to benefit from any drug effect if your drug is actually effective. So we really want to have models that can target exactly the right people that are the most appropriate for your trial. And so then we can increase your trial's chances of reaching its endpoints.
Yeah, it's getting the right people at the right time.
Yeah, exactly.
Yeah. We'd like to have at least some time for questions. Yeah, in the back there.
Who's going to pay for this? So in Canada, is it payers? Is it going to be the provincial health authorities or the government itself? Because individuals will not pay for this. We're in this business. I'm with a company called Molecular Ingram out of Vancouver. We do early detection of exactly these kinds of diseases, but nobody wants to pay for it out of their pocket. And so we either have to shift our dynamic here and say, this is a really important thing. And so there's government people at this conference, there's physicians at this conference, but I can guarantee that we'll all walk out of here going, this is a fantastic thing, we've got to do it. There are crickets
Yeah.
by Saturday. So who do you see as paying this? Because insurance companies don't want to pay for it.
Yeah. It's interesting. We were actually just talking about that this morning in the context of robots again, because one of the companies we work with, Intuition Robotics, has a robot called LEQ, which is meant to reduce loneliness, which is one of the risk factors for dementia. And it's expensive, right? So it's not going to be accessible to everyone. And this is one of the issues that's really concerning is you don't want solutions that are going to help just the, upper 1%. when they might not even be the ones that are the most at risk. What was interesting with the release a year ago of Intuition Robotics Solution LEQ is the state of New York saw so much value in what it could be doing to support older people that it bought a whole bunch of these and distributed them to people in vulnerable populations. So that is, I think, a great model. Now, can we convince Alberta to do that? Can we convince Ontario to do that, or the government? I mean, I think that the case is going to have to be made. So I don't know. What do y'all think about?
I'd just like to add a minor version of what you just said. And some of you may have seen the documentary Alive Inside that came out a few years ago, where the idea was to take iPods around to nursing homes, play music that residents related to, and caused some perhaps short-term, but nonetheless transformations. And at the end of the documentary, it was said that none of the long-term care homes or nursing homes would pay for a bunch of iPods.
Yeah.
I think this is it's an important question in a business. If you're running a business, has to figure this out. If we look at precedents, this has always been the issue over the last 100 years for all kinds of different technologies. And at the end of the day, my experience has been around like the alignment of incentives. Who is incentivized to do what? So it could be, foundations. So you've got the Heart and Stroke Foundation. They have they have a mission to decrease stroke. So if there's, whether it's preventative measures they do, spreading the word, they put money and effort into that. Provinces are looking at, how do they take care of more people for less dollars? Can you show that? So it's all about alignment of incentives.
Yeah. There, yeah.
Yeah, I'm from the Medical Technology Association of Canada. A number of our member companies, particularly on the diagnostic side, are active in the diagnostic space around Alzheimer's. I'm curious, in particular, I think it was Jay, you had mentioned your perspective around, a couple of you actually, this gap between diagnosis and treatment options. And while I recognize, I think that's a very legitimate gap, I think a lot of the folks from my association would say, if someone is going to be diagnosed with Alzheimer's or dementia, and it has sort of degenerative elements, that they have a right to use the time that they have to make effective decisions about family planning and the future.
Yeah.
I wonder, could you reflect on that?
Me?
Even if they can't cure it, isn't there some sort of benefit of knowing so you can plan, et cetera?
Well, I briefly alluded to that when I talked about it by saying people like to make plans, take care of their families, and so on. The actor Chris Hemmings discovered he had a double dose of the gene ApoE4, which would raise his risk for dementia, and decided he would take time off. So I don't quite know, I didn't understand that response. I mean, maybe he's taking time off to do the very things that I suggested, that, you make plans for the future. Maybe you travel, I don't know. I just think that there are probably an equal number of people who would be devastated with that diagnosis when there's no immediate treatment. So it's a fine line. It's up to the individual.
Yeah. Susan.
Hi, my name is Susan Blanchett. I actually started my company because my father was diagnosed with dementia at 51 with no genetic markers. There's this recent case in China, in one of the biggest chemical producing cities, where a 19-year-old is now diagnosed with dementia.
Wow.
What are your thoughts on prevention through air quality improvements?
Yeah. Susan has a company that has amazing
Genetically modified plants
ways of
toxins.
removing toxins from the air. It's really cool. So that is a risk factor, right?
Yeah.
So the pollution, air quality, does someone want to speak to that?
Just briefly to say, it's thought that the air pollution risk is related to the smoking risk. Many of the same particulate matter, much of the same particulate matter.
Yeah. So it's interesting because you don't think about things like that, but there can be risks that we can address in lots and lots of different ways. We're a little bit over time, but there's one more question. Sorry.
I'll make it a quick one.
Yeah.
Are there any diagnostics on the horizon right now that actually help contribute to the treatment? In many cases, there are diagnostics that help elucidate the underlying
Yeah, so there's some imaging options, but unfortunately they're quite expensive. They usually rely on PET imaging, so it's with a radioactive tracer, and they're usually only available in higher resource settings like urban teaching hospitals, and of course in richer countries too, right? So, you know, you can use amyloid PET imaging or tau imaging, for example, to look at the pathologies that are specific to Alzheimer's disease. You could look at, you could use FDG PET to look at brain metabolism patterns to see if it's a more frontal temporal dementia type of problem, for example. But I think it's hard to bring these technologies to scale. And so I think we're gonna have to, you know, with the advent of blood-based biomarkers, I think that's gonna be the real game changer, yeah.
Yeah, and I think like our lab and some of the other, there's other companies around that are doing this kind of work as well, are taking advantage of the fact that different kinds of dementia affect different parts of the brain earlier. Mm-hmm. So even with things like vision testing, right? There's certain kinds of vision tests that you can do that might be more active, that are related to the areas impacted by Alzheimer's or impacted by frontotemporal dementia or vascular dementia or Lewy body, et cetera. So that's some of the sorts of things that people are looking at, is even going beyond these traditional imaging approaches. Are there approaches using, you know, behavioral tests or EEG tests and other kinds of things that can maybe not just detect it but differentiate it? With that, I just want to say, if you can sum up in one last word, the panel, and then we're going to end. Starting there.
I would say impact.
Impact.
Innovation.
Innovation.
One word?
Yeah.
Two.
That's
That'll
two
be
words.
my
That
word.
was 2 words. TBD. That's excellent. Thank you.
Diversity.
Diversity and TBD. And thank you all for your time and your engagement.